Here in southern Spain, the sun shines for almost 12 hours a day in July. It's an amazing resource for the country. The problem is, when electricity demand is at its highest, it's not always sunny. Indeed, it could be in the middle of the night. So they've got to be clever about not just how they capture the sun's energy, but how they distribute it and store it as well. Torresol was established 3 years ago by the Spanish engineering company Sena and the Abu Dhabi-based renewable energy group Masdar to develop and build concentrated solar power plants, or CSPs, all over the world. At this location near Cadiz, Torresol is building two 50-megawatt parabolic trough solar plants. In fact, in less than 4 months, they have built 180 kilometers of these troughs, and that is about 1 kilometer a day.
We are just in front of the troughs. The light
These are these huge mirrors, parabolic mirrors.
Yes, this has a parabolic shape, and then when oriented or tracked into the sun, the light is concentrated on the tube. Then we are passing oil through the tube. The oil gets pretty high temperature.
Yeah, heats up.
Yeah, and then we deliver that oil, very hot oil, to the central block, or the power block, we call it. And then there we produce steam from the heat that has been captured by the
So the oil boils the water,
exactly.
That turns into steam,
exactly.
And then what happens?
And then, well, the steam is passed through a turbine, and then the turbine produces electricity.
Now, so far so good, but actually what's interesting about this is you do something special, because you manage to store the power
Exactly.
in a way that no one else in the world is doing. Tell me how you do that.
Yeah, part of the oil is not directly used to produce steam. Part of the oil is diverted to be given the heat to molten salts.
Molten salt?
Yeah, those are sodium and potassium nitrate. Then they store that heat, and then whenever we decided, for instance, in the afternoon, which is the time in which the peak of the electricity is at the highest point, is when we can deliver the excess of energy we have captured during the day.
So you've invented a salt-based battery to store the power from these miles and miles of mirrors.
Exactly. That's exactly the point. I mean, the system is working like a buffer to accumulate the energy and then to deliver the energy whenever it's required.
And if you stand here, you can also get a great suntan.
Oh yes, of course. You can get fried. Yeah,
perhaps not so funny. Well, from here we're heading about 100 kilometers northeast to see what Torresol described as the future for solar energy storage. There's something rather unworldly about this landscape. It's very different from the other solar plant we went to. You can see these mirrors everywhere. They're catching the sun's rays and reflecting them onto the tower up there. Now, if you can see that black band, the idea is that they're focused on that. The temperature then gets to an astonishing rate, 565 degrees centigrade. They pump liquid salt up the tower. The salt gets burning hot. They bring it down again, and it goes into that metal container. What you then have is a store of enormous energy, thermal energy. When they want electricity, they release it. It turns water into steam. The steam power turbine. The turbine makes electricity, and that means you and I can turn our lights on.
Well, this is the first in the world. We are planning to do some other very soon. But obviously we are breaking the ice. I mean, this is very new, and everything has to be tested.
Although it's incredible to see some of the effect of the power of the sun here combusting particles in the sky, effectively this is very simple stuff, if you don't mind me saying that. I mean, it's a mirror shining at a block. Why haven't anyone done this before?
Well, what you see looks simple, but it is not. The control system for 2500 heliostats tracking the sun and then taking the right angle to focus into the tower is not an easy task.
And so although we're surrounded by these solar panels or these mirrors, the clever bit isn't this at all, is it? It's the bit we can't see. It's how to melt salt and make it a store of energy.
And handling in general, the handling on the molten salt is something that, I mean, it's not rocket science, but yeah, needs to be experienced and learning from the experience.
And is that your vision of the future, that this sort of technology is the thing that's going to replace gas and oil when those commodities become just too expensive?
Most of the energy in the future will be produced by these kind of systems, obviously by renewable systems. Otherwise, we cannot continue burning oil forever. In particular, to produce electricity, my vision is that very soon, people is going to be using this kind of technologies and not just using oil for producing that.
Torresol's chairman, Enrique Sendagorta, believes his company has a key advantage over other renewable sources.
We now are very confident that the technology works. So we have done a number of solar plants that actually are operating and functioning very well. But we're only at the beginning of the deployment of this technology, really.
How much energy are you actually producing? I want to get an idea of the scale here.
We can store energy for as much as 16 hours, up to 16 hours. What this means is that during the month of April and the month of October, we can actually produce energy on a 24/7 scheme, actually day and night. We are not dependent on sunlight or solar irradiation for the production of our energy. And we can actually deliver the energy to the grid when our customers need it. We can adjust our supply to the demand curve. But there is something very unique about Spain, I believe, and this is that the Spanish government had the vision of developing solar thermal energy actually several years ago and implemented an adequate regulation. In Spain, actually, we have a system of feed-in tariffs. What this means is that the government is willing to pay us an extra premium, to compensate for the fact that we right now are not fully competitive on a cost basis with other carbon technologies, such as combined gas cycles or carbon plants, etc. But of course, you are aware that we in Spain are within the within the European Union. We are aiming at achieving this objective of 2020. And so 20% renewable energy by the year 2020. And actually this prompted really a very early development of a well-orchestrated plan, and it is in the context of this plan that the Spanish government decided to help Spanish companies developing solar thermal energy.
You're getting a government subsidy to make you competitive. Without that subsidy, how much more expensive would your energy be compared to traditional carbon energy?
Right now, solar thermal energy is basically at the beginning of the experience learning curve. So we are only starting now, basically. At this moment, we are perhaps 3 times, the cost of generating is perhaps 3 times higher than with our state-of-the-art combined gas cycle facility, for example. Now, of course, there are only about 1,000 megawatts operating in the world. So today we have something in between 10 and 20 solar plants operating in the world. And as we deploy this technology, we are very confident that we will indeed become fully competitive. We will reach grid parity.
Are you expecting other countries to follow this sort of path, to use this technology?
We are all aware that Spain, southern Spain in particular, is in a good location, but of course there are many other areas in our planet that are ideally located in terms of solar irradiation. I mean, think about Northern Africa, think about the Gulf region, or perhaps Southwest United States. Why has solar development started here? I believe because of the regulatory framework provided by the Spanish government. But we need the right regulation, not only the sun, we also need the right regulation, at least for the next 10 years.
Are you exporting to other countries this technology?
Yes, I mean, we have started to also deploy our technology in other countries. Some Spanish companies are already operating in the Gulf area, others are operating in the US, and yes, we are starting to be able to export this technology to other nations.
And how significant a moment do you think we are right now in the development of this sort of power?
Around the equator, there are many areas in the planet that would be ideal for the development of this solar thermal energy. So I think, by the year 2020, when we are fully competitive, and we probably will be living in an economy with very high oil prices and very high gas prices, and uranium will be decreasing, etc. Frankly, I see a world where solar thermal might have a very dominating position.
There's been something very revealing, I think, I've learned during this film, and that is, whilst all the noise and attention has been about how to generate power from renewable resources, there's also been something, I think, of a quiet revolution, working almost unseen to solve one of the central problems of renewable energy. Generating renewables, well, that's almost the easy part. It is storing it for when you need it, which is difficult. And I think when we look back in 10 years' time, let's say, it may well be that the technology we think revolutionized the world of power were not the impressive looking turbines, the tidal machines, or indeed solar power itself, but the quiet cleverness of getting a grain of salt to store the energy ready to be released whenever we want to turn on our lights. And if that happens, that really will be something truly amazing. To find out more about the series and watch interviews and clips from the programmes, go to www.horizonsbusiness.com.